Okay, so now what is really, I've been talking about this. So what is Neo4j? Again, Neo4j is basically a graph database, and we are going to be working with graph. Okay, so we are going to be working with that. We are going to be seeing that data structure, and that's what we have to do. We are going to have the properties of a graph. Now you have to be really careful with this. The Neo4j guys, if you go to the website, they claim that they support full AC properties. Okay, they claim this, but you have to be careful, because if we know that that is going to be impossible to satisfy all the three properties of the cap theorem. Okay, so you have to be really careful how you understand this. Probably they support this, but not in a distributed way. Okay, so because it's going to be impossible to have everything, so you really need to be careful. For example, then later on in the website they also say that there is high availability. Okay, so we know that it's going to be impossible, and always I strongly recommend that you look and try to understand what they really mean when they say we support all the full AC properties. So they support transactions, and then they start saying that it's highly available. Okay, so really you really need to do that. Probably when they say that is, and I say probably because I don't know all the details inside all the internal properties of this particular graph database. This is a commercial software, so they don't provide all the details, and we need to be able to infer a couple of things. Okay, my guess is that this is not going to be, or one of the versions is not going to be distributed, and in that context it's possible that they satisfy AC properties, but then it's not going to be distributed. We know that it's impossible to satisfy all the properties of the cap theorem. So you have to be careful when you read this, and you will be seeing that a lot of NoSQL databases, they start claiming that they support all the full AC properties, and so it's impossible to satisfy all the properties of the cap theorem, and we covered that already. Okay, so something important here is that it's going to be we can manipulate important amounts of data. Okay, and with loads of nodes, billions of nodes, billions of relationships and properties. I will be talking more about these properties and so on and so forth. It's basically it's going to be a server that you are going to be installing, and there is also an API in order to interact with that. You can interact with that, for example, with Java. We are going to be using the web browser in order to create a graph. And the key concept here, we are going to only spend a couple of lectures on this particular graph database, and then we move to Mongo. We are not going into all the details, only we want to focus in the query language of this particular library. Okay, as I said before, this is going to be really good, and as you can go and look in most of the applications that they have, they recommend this, in particular for social network, as the social network in the context is going to be, the concept is going to be basically a graph. And in that context, we can exploit the properties of a graph. For recommendation in e-commerces as well, this also, we can represent that as a graph. For pathfinding, okay, we can look, for example, the shortest path between these guys, between this person and this person in the Facebook graph, and things like that. And they have they also have good implementations of popular algorithms for looking for the shortest path, iStack and some other algorithms like that, in case you are familiar with that. Okay, and the idea here is not, again, the key concept here is to use the database and use the implementations that they have and interact with the database. And here I'm not going to be asking you to implement this graph method or so. We will be using what is in that particular library in the graph database. Okay, so basically here a couple of things that I want to mention. I recommend that you probably, but now you already have a contact, you have information in order to access the database that we have in UCC, but I recommend that you have your own database. Okay, that you install your own Neo4j in your own computer. It's going to be free. If you install the community edition and the desktop edition, as far as I know, these two are going to be free. Of course, there are limitations, okay, but the free version is going to be enough. We are not going to work with massive graphs. We are not going to be distributing or parallel things that they support. So the desktop version, the community version should be enough. And for example, here in this link, you can have a look at that. They explain how to install that, at least in Windows. Okay, so in general, I would recommend that you try to install that in your own computer. You will have access to, you can manage your database, you can do you will have more flexibility, okay? But you can also have access to the one that we have in UCC, and probably you already have that information now. And if you want to access that, if you have your own, if you install your own local database, all you have to do is you open your web browser, and then you go localhost and 7474. Okay, this is going to be the port that this is going to be using. That's something that we can change, but it's not the interest here. We don't want to change the configuration. Just use the default configuration. That's enough in order to interact with the graph database. And basically, this is going to start this. You open this website, you will be looking in. It's going to look something like this. This is what you will be looking. Probably it's going to be asking for a password and a username the first time, and then we will be interacting. And basically what we are going to be doing here is that at this part of the web browser, we are going to be writing the queries, and this is how we are going to be doing in order to interact with the system. Basically, this is just a quick introduction of how things are going to be, on the structure of this Cipher query language. Okay, as I said, one of the key and important properties of this is that they want to have a standard language, which is quite nice as far as I can see. Okay, so basically how this is going to look like, basically this is if we want to represent this relationship here, for example, A likes B, basically we need to create node A, and if we want to create a node A, basically in Cipher all we have to do is we open, okay, we open this parenthesis A, and then we close it, okay, and this is going to represent this particular node. And if we want to represent the likes, we're going to have this minus, we open, we have this, and likes, okay. This is just basically the notation that we're going to be using, and then we have the arrow. The arrow is going to be indicating the direction, okay. Here we have a directed graph, so basically we are saying that goes from A to B, and this is going to be the property of this connection, of this relationship. It's going to be likes, and it goes to B. Okay, so basically, as I said, this is I'm going to be showing a few examples here. So basically, this graph is, we are going to be representing this using this particular notation in the query language. And basically, this is just a quick introduction of how this is going to look like, and you will be writing something exactly like this when you have to write your queries. Now we can have different things. We can have, for example, if you want to query data, you have to use the match, okay? And this is going to be close to, for example, the select that we have in SQL. Okay, when we want to get data, okay, we can use match, and then we can also add constraints. Okay, we can to say all, for example, we can have all the likes of a particular person. Okay, so we can also constrain that. We can add conditions. Okay, where in that case we can add conditions, and we can have different ways in order to indicate the conditions. Okay, but basically we can say match in order to get data from the database, and then where in order to add conditions, and then return is just going to indicate the information that we want to return. Okay, for example, we want to return all the friends of particular person, John. For example, this is more or less how a query is going to look like. Okay, match. In this case, we want to get all all the nodes of John. Okay, we want to look for John. The node of a person that the name is John is going to be, the relationship type is going to be friend. And for example, here basically all we are saying is that we want to get all the friends. Okay, if you don't put anything, it's going to be getting everything that is connected using this relationship. Again, probably this is going to be confusing now, but I will go step by step. Okay, and this is going to be, so basically what we're saying here is that John is going to be connected using the friend relationship to some other node, and then that particular node is going to be connected using the first relationship to some other person. Okay, and that person is going to be, so basically we name this one John, and we name this with this particular variable. Okay, basically it's going to look something like this. Okay, so this is John, this is the friends, and this one is friends with some other person. Okay, and we return this one and this one here, but it could be, and this one here. So basically all the friends of this other person. Okay, so basically, and we return John and these guys. That's basically what we want to return. Again, if this is going to look a little bit confusing, and that's something that we understand, but we are going to go with examples in order to understand this query language. Hopefully I'm going to provide enough examples in order to clarify this. Okay, so basically we can, again, this is just the introduction, okay? So don't worry if you don't fully understand this at this point. And what we want to do is that we want to have we want to interact with the database, so we want to create nodes. Okay, you want to create nodes, so you are going to be creating this particular node with these properties and so on and so forth. We want to merge. Okay, basically we want to combine information. For example, nodes that we already have, we want to update. If you like, it's going to look like more or less a little bit of the update. We want to delete, and we want to order by, for example, the information that we get, and so on and so forth. Okay, I'm going to try to explain this with a few examples as we go. And now what we want to focus most of the time is going to be in the Cipher query language. As a general query language, we will be using Neo4j in order to interact with this query language. Okay, so basically if we want to represent relationships, okay, we can use this way in order to represent a relationship. Okay, but this is just a way in order to represent relationships. Okay, this is going to represent that I want to get two nodes with any particular relationship. But here the key point here is that if we want to create two nodes, okay, I'm going to say that we can use the create. So basically we say create, we create the node. This is saying that we want to create a node. We name that node that we create here N1, okay, but this is like the variable. And then we are going to have a relationship, and this is going to be the type of the relationship. It's going to type R, and then another node N2. And this is going to create a graph that is going to look like this, okay? So one node using the type of the relationship R, probably you don't see it here, but it's not very clear here, but here we have the R because this is the type of the relationship to another node. Okay, so this is pointing to this N1, this is pointing to this N2, and the type of the relationship, because we can have multiple relationships. This is just, and then if you want to create that, you just hit execute, and then that's going to start populating the database as we go. Okay, this is just an example of how we can create. All we are doing here is creating two nodes in the graph and connecting those two nodes with R. Okay, now we can start adding labels. Okay, what we call labels in the objects that we have in the graph. For example, we can add a label to the node. Okay, we can say that label is going to look like, if you like the type of this node. So we're going to say that the type of this node is person, or the label of this node is a person. The label of this other person, of this other node is a person, and then the label of the relationship is friends. Okay, so basically we say that there is a relationship between a person and another person using the friends. Okay, and that's why we have to use this notation here, indicating that this is going to be the label, indicating that this is going to be the label, and indicating that this is going to be the label. Okay, we want to get a person. This is going to be the syntax here. This is going to be a person. This is going to be the relationship is between a person and another person using the friend relationship. Okay, let's and we can also start adding more information inside that, what we call properties of the node. Okay, in this particular case, we are saying that, okay, this node is going to be a person, and now we can add additional information, properties, in order to indicate more information about that particular person. Okay, for example, we said that this node, the type, if you like, or the label, we use here in the label, and you say type in order to have some similarity with what we have in a programming language, for example. But here we say that this is the label of this is a person, and then inside that we can have additional information, so the name of this person, the age, the salary, or any other information that we have. And this is the notation that we are going to be using. So name and whatever name we have, name and whatever name. So basically this person, the name of this person is going to be Peter, and the name of this person is going to be Lucy. And we are saying that we have a connection between Peter and Lucy. Okay, and that connection is going to be friends, because these two guys are going to be friends in my database. We can also have an ID. In order to access that information later on, we can use, for example, P1 is going to be representing this particular person. This is like if a variable, if you like. So P1 is going to represent this particular node, okay, this particular node, and R is going to be representing this particular relationship, and P2 is going to be representing this. It's like getting a reference to that particular object, and later on in the query we can access that particular information. Okay, and here we have the query language. Okay, and I think that we can finish today's lecture. Again, try to have a look at this. This might look a little bit confusing, okay? And that's normal at this point, okay? We need to practice and we need to get more familiar, and in particular because it's different, okay? So most of the students at the very first time that I introduced the concept of Cipher, it's a little bit difficult to get the mind inside this particular structure, but we are going to be try to have a look at the material, and we are going to be looking into examples in order to clarify all the details, okay?